Hello friends, welcome back. In this session, we will learn about the time and space complexity of algorithms. In the last session, we have seen the approaches to design an algorithm and control structures used in algorithms. So in this session, we will see time and space complexity of the algorithm. Okay, so what is time and space complexity? So before to see this time and space complexity, let's see the example of some algorithms. In the last session, we have seen approaches to design the algorithms and approaches to design the algorithm and control structure used in algorithm. So let's see the example for that. So here you can see so many examples are given for algorithms. So this is our first problem. So in the first problem, it is saying write an algorithm for swapping two numbers. We have seen in our C, C++ or any other programming language how to swap two numbers, to swap two values. So here we have to write an algorithm to swap two values. Value, that could be any type of value, number, string, whatever. So very simple this logics we can write an algorithm. So first one is, at the first step we need to take input first number as a input we have to take, because if you see from the problem statement, write an algorithm for swapping two number, it means we need two inputs. Two input we are taking in form of a and b. Input second number as b, input first number as a. Set temp is equal to a. Now temp is another variable, that is a. Temp is a third variable that we are taking, and temp is storing value for value of a only. Whatever the value we will enter, the same value temp will hold. Then what we are doing, we are setting the value of b into a at step 4, and step 5 what we are doing, we are setting the value setting the temp value to b variable, and then we are printing a and b and exit or exit. That's it. So this is only a very very basic you can say the example of algorithm swapping two number. Okay, next one, write an algorithm to find the larger of two number. Yeah, two numbers are there. From two number you have to find which one is larger, which one is greater, which one is higher, which one is lower. So here also we will take input first number as a and input second number as b. In first step we will take input for number a, in the second step we will take input for number b, and in third, this is a third step this complete is a third step. Here one conditions we are applying, conditions we have seen in the last session, condition, repetitions and sequence. So this is a condition. Here condition is what? If a greater than b, if a greater than b, then print a. Otherwise if a less than b, then print b. But this is also not required. This if inside else, this if is also not required, but that might be chances that a equal b. In that case we are applying here if a less than b, then we are printing b. But if we want to check for the equal condition, then we will write else. Inside that one directly we are printing the numbers are equal and end of if, and then after end of if, this end of if is coming here because of this if else. Simple. And we are ending the algorithm. Third one, write an algorithm to find whether a number is even or odd. Yeah, that is also similar. Here we have to take only one input, because one single number we have to check whether that is an even or odd. How the number will be even? If there is a remainder, if there is a remainder 0, it means number is even. If we divide by 2, if we divide by any number, divide any number by 2, and if remainder is 0, it means the number is even, otherwise number is odd. So at first step we are taking input number as a. If in the second step we are making comparison, if a mod by 2, so mod by 2 will give the remainder. If a mod by 2 is equal to 0, then print even, else directly print odd and end of if, and after that one we are ending the algorithm. Simple. Next one is in the fourth one, write an algorithm to print the grade obtained by a student using the following rules. What is the rules? Rules are this one. If if marks is less than 40, grade should be D. If the marks is coming within the range of 40 to 49, grade should be C. If marks is coming between 50 to 59, grade should be B. And if the marks is coming between 60 to 75, grade should be A. And if it is a more than 75 or above 75, then grade should be O. So this should be the logic. So one number only we have to take. So enter. So one number we have to take as an input. So in this algorithm, first we are taking input M. We are taking input a variable inside M, that is a marks, and here we are making the conditions. If M greater than 75, yeah, definitely here is the rule. If the number is greater than 75, grade should be O. Grade should be O. So we are printing. Another one, if M greater than equal to 60 and less than equal to 70, less than 75, in that case print A, means the grade is A. If so, these all are the different steps. They are not having in the same steps. If marks is between 50 to 60, print B, and so on, and last it is ending, end of if, and end the algorithm. Next one is write an algorithm to find the sum of first n natural number. Very simple. You have to write the you have to write an algorithm to find the sum of first n natural number. N natural number, which are the n natural number starting from 1 to n, that will start from 1, and you have to make the sum of that. So how we are doing? First we are taking input n. N is what? N is the last number. N is the maximum limit from like it can be 100, 10. So first 10 natural number, 5, 10, 50 natural number, like that. So n is any input. Next one is set I is equal to 1. I is equal to 1. That is a what? It's a loop. To start the loop means we have to start from 1 to n. So 1. Sum is equal to 0, because sum by default sum will be 0. We will start adding values here. Repeat step 4. Which step? 4 step we have to repeat while n less than equals to n. While I less than equal to n. And in fourth step, what we are doing, set sum is equal to sum plus I, whatever value is I. How much I is there? I is 1. So sum will be 1. Next time, and after setting sum is equal to sum plus I, we are incrementing I by 1. And the next time I will be 2. So sum will be 1, 1 plus 2, 3, 3 plus 3, 6. Like that it will go on, and end of loop. This is a loop. Repeat step 4. This fourth one is a loop. End of loop. Print sum. Whatever the value of sum will be there, you can print, and end of the algorithm. So in this way we can find the sum of first and natural number. But see, this is a one approach. This is a one approach. But if you see the power of mathematics, you no need to repeat this loop of 100 times, 10 times, 20 times. Directly you can apply the mathematical formula n into n plus 1 divided by 2. Same it will give same. Okay, but whatever you will prefer, you go. So this is the examples of algorithm. Now here we have to see the time and space complexity. What is time? Time, see, this algorithm will take some time to be executed. But if we use here some mathematical operations to do these functions, this loop we can replace with the mathematical function n into n plus 1 divided by 2. Very simple. Your computer will do this calculation in very less time. So that is a time complexity. You have to adopt an ideal algorithm that will take less time, less computer time. That is called time complexity. Another one is space complexity. Space means how many inputs you are taking. Suppose here is n is a one variable. It will acquire some computer memory, your RAM. I, another variable, that also will ask for some memory from your operating system to store that I. Sum also will be stored. So these 1, 2, 3, 4, 3 variables that will be used during this algorithm execution. So how much memory they will use? One variable, if it is using 8-bit, so 3 variables means 24 bits it will use. So that is space complexity. Time complexity, how much time, that could be in seconds, milliseconds, whatever parameter you use. So that is called time and space complexity. So analyzing an algorithm means determining the amount of source means such as time and memory needed to execute it what? Algorithm. Analyzing an algorithm means determining the time of resources could be a time, memory needed to execute it. Algorithms are generally designed to work with arbitrary number of inputs. Arbitrary numbers of inputs means how many inputs we know, so that the efficiency of or complexity of an algorithm is stated in terms of time and space complexity. So what is time complexity? Time complexity of an algorithm is basically running time of the program as a function of the input size. That is a time complexity. Suppose one algorithm is running into your computer. To completely to get executed that algorithm, if your computer that algorithm is taking 1 second or 2 second or 3 second time, that is a time complexity. That means that amount of time that your algorithm is taking to be getting executed, that is called time complexity. An algorithm basically the running time of program as a function of the input size, called time complexity. Space complexity, how much memory, how much size of memory your algorithm needs to be executed into your computer system, that is called space complexity. The space complexity of an algorithm is amount of computer memory that is required during a program execution as a function of the input size, called space complexity. Time complexity, the running time of the algorithm, called time complexity. Space complexity, the amount of computer memory that is required during a program executions by an algorithm, called space complexity. Okay, in another words, the number of machine instruction which a program executes is called its time. Yeah, simple. The number of machine instruction which a program executes is called time complexity. This number is primarily depend on the size of the program's input and algorithm used. Generally, the space needed by program depend on the following two parts. So how will you calculate the space? Some is fixed part. We know in our algorithm sometime it is a fixed part. We set some value, that value will be remaining same, will not change. So you no. So it varies from problem to problem, and it include the space needed for storing instructions. Yeah, definitely instruction will be fixed. Suppose if you have 30 lines of statement, so 30 instruction only it will be. There will be no change in 30 instruction. If you have declared any constant variables, that value will not never change. That is also a fixed. Or some variable that will not change, or any structure or any other variable that will store the reference or something like that, or array. So that is also fixed part. Another one is variable part. Variable part also vary from program to program, include the space needed for recursion, stack. Yeah, if you have program has recursion, you also can't predict how much memory it will take, but recursion will take some memory. And the structure variable or any other variable that value will be changing inside a loop or something like that. Or if you are creating any variable inside a loop, definitely when the loop is over, memory will be get destroyed. When the loop is again running, memory will be created. So that depends. Okay. So however, running time requirements are more critical than memory. Sometimes running time is required more critical than memory. Therefore, in this section we will concentrate on the running time efficiency of an algorithm. That is important. Sometimes what happen, computer memory, we generally have a more memory. 8 GB RAM, 10 GB, 8 GB RAM, 60 GB RAM, 30 GB RAM, 64 GB RAM. You can install, that's problem. But time is very important sometimes. Sometimes time is very important. So we will mostly concentrate on the time efficiency. So time efficiency means one is roast case. What is roast case? Roast case means the upper bound of running program, that is called roast case. Like if I say I have one algorithm A, so that algorithm A, if you give any input, the maximum time it will take, like you can say 5 seconds. It will not take more than 5 seconds. That is the assurance that we can give. Like that is the upper bound. Yeah, it might be this algorithm will executed in 1 second, or it might be that algorithm will take 2 seconds or 3 seconds. But the maximum time that this algorithm will take, that is a 5 seconds. It will not take more than 5 seconds. So that is the upper bound of any running time of the any input. So that is called roast case running time. This denotes the behavior of algorithm with respect to the roast possible case of input instance. The roast case running time of an algorithm is a upper bound of the running time of any input. Therefore, having the knowledge of worst case running time give an assurance that the algorithm will never go beyond the time of limit. So the so the worst case is what? That is the upper bound of time that will define the maximum time that will an algorithm will take that month, and that will also give the assurance that the time will not go beyond to the roast case time. So that is roast. Next one is a best case. Best case means you can say the term best case performance is used to analyze the performance under optimum condition. For example, the best case of simple linear search is array occurred when the desired element is the first transaction. See, minimum, you can say best case means minimum time. What can be the minimum time? Suppose if you are searching an element from the array and you see the element is available at first index only, then definitely your algorithm is executed in first iteration. It will not take any much time. And if your array is 100 in size, in that case, if the element is available at the last index, in that case you have to traverse all the elements. So that is worst case. And if the element is available at the first index, that is the best case. Best case means the minimum time. Minimum time means whatever the possible it can do. Okay. However, while developing and choosing an algorithm to solve a problem, we hardly base our decision in the best case performance. It always recommend to improve the average performance and roast performance of the algorithm. Okay. That is the best case. Roast case, the upper bound. Best case, the lowest bound. Average case, generally we will searching any number, that number will be within the range. The average case running time of an algorithm and is an estimated of the running time of average input. Average input you give, it will take 2-3 seconds. That's it, the average. Maximum 5, less than best case 1, average if you say 2, 3, definitely it will be getting executed. So that is average input, average time. And it specifies the expected behavior of an algorithm when the input is randomly drawn from the given distribution. Average case running time assume that all inputs of given size are equally, like we will define like this will be the mostly input, this type of input which will come, this value will come. So in that case we can define this will be an average case. Okay. Amortized running time. Amortized running time refer to the time required to perform a sequence or related operation average over all the operation performed. Amortized analyze guarantee the average performance of each operation in the roast case. In the roast case also it will give the average performance, that is amortized running time. Okay. Fine. So here one concept is coming, time space trade-off. What is time space trade-off then? See, we have to choose one from two. Suppose if you want to go Bengaluru from New Delhi you want to go to Bengaluru, you have two options. One, you can go by train, and another one you can go by flight, but both has a different requirement. Like if you go by train, you have to spend time, definitely, because if you go by train from New Delhi to Bengaluru, it will take 2 days. it will take time, or 1.5 day it will take. But if you go by flight, it will take 2 hours only. It will take 2 hours only. And another side, if you go by train, you need to spend less money, like 800 or 900, that's it. But if you go by flight, you have to spend 5,000, 6,000, 7,000, 8,000 rupees. It depends on their current price rate. In the same case, but in case of, if you want to go by train, your fare charges will be very less, but in flight fare charges will be more. But in flight you will reach in 2 hours, but if you go by train you will reach in 2 days. So that you have to decide. How will you decide it? You will decide on your choices. If you have a time but you don't want to spend money, you have a time but you don't want to spend money, then that is a preferable to go by train. But if you don't have a time and you can spend money, definitely you should go by flight. So that is called time space trade-off. You have to make balance, you have to decide which one you will choose. In the same way, in computer programming, there can be more than one algorithm for a problem. One problem, for that problem solution, there might be more than one algorithms. One algorithm that taking less time to execute, but taking more CPU memory, your computer memory, that algorithm is taking more, but it is executing very fastly. Another way, that algorithm is taking very less memory, but it is taking more CPU time to be getting executed. So in that case, you also have to decide on the basis of your computer, your architecture, your architecture designs, or your architecture, how much memory your computer has. You have to decide on that only. So this is called time space trade-off. The best algorithm to solve a particular problem is no doubt that one that require less memory space and take less time to complete its execution. But practically, designing such an ideal algorithm is not a trivial task. This can be there can be more than one algorithm to solve a particular problem. One may require less memory space. Yeah, there can be more than one algorithm to solve a problem. So suppose you have a two algorithm. One algorithm require less memory space, while the other may require less CPU time. Thus, it is not uncommon to sacrifice one thing for other. Hence, there exists a time space trade-off amount algorithm. We have to make the balance, which one we should prefer. So if a space is a big constraint, if space is a big constraint, then one might choose a program that take a less space at the cost of CPU time. On the contrary, if the time is major constraint, then one might choose a program that take a minimum time to execute at the cost of more space. So that is called time space trade-off. We have to decide which one we should choose, or we can design a third algorithm by these two that will minimize both. Time should take less, memory should take less. We can optimize. That is in our hand only. Okay, fine. So this is called time and space trade-off. Next one is expression of time and space complexity. How will express the time and space complexity? How? So the time and space complexity can be expressed using a function fn. Now what is fn? F stands for a function, that's okay. What is n? N is the input size. If you are giving 2 input, 3 input, how many inputs variable you are taking, that is called input size. So function n is the input size. Expressing the complexity is required when we want to predicate the rate of growth of complexity as input size of the problem increase. Yeah, definitely if input size is increasing, then definitely that will increase the memory size. Definitely there are multiple algorithms to find a solution to given problem, and we need to find algorithm that is the most effective. For that, why we need to express time and space complexity. Why we need to express the space complexity? So that we can find the most effective algorithm and we can predict how much memory this algorithm is taking to execute it on the basis of input size. Okay, and the complexity can be expressed using function fn. F is a function, that you can say that is a function only, or n is the input size. Okay, the most widely used notation to express the function fn is big O notation. It provides the upper bound for the complexity. So big O notation is generally used to find the space and time complexity of the algorithm, and that will give the upper bound of the complexity, upper bound of time and memory both. Okay, so that is big O notation. We will see the big O notation in the second session of time and space complexity, because this is not completed yet. So in the next session we will see the algorithm efficiency. We will need to find an effective algorithm. Okay, so we will see the remaining part in our next session. So I hope you like this session. Please subscribe my channel and we will see you in the next session. Till that, bye bye and thanks for watching.